Okay, welcome to This Explainer. Today we're diving headfirst into the absolutely epic, centuries-spanning evolution of human precision. It's honestly an incredible story. We're talking about how we literally learned to measure, control, and ultimately wrap our heads around the incredibly complex world around us.
So how did we get here? We're going to trace a massive journey today. We're going all the way from ancient survival tactics right on the banks of the Nile, straight through to the exact rigorous math of modern physics. I mean, it's just fascinating to think about, right? The exact same human species that once had to flee changing weather patterns is now, today, completely capable of calculating microscopic fractions of a millimeter. Just wild.
And the path we took to get here was pretty drastic. We started out with the early philosophical musings and classical texts of our ancestors, and slowly but surely moved all the way to the highly formalized, super precise tools we rely on today. It's a total fundamental shift in how the human mind actually approaches reality.
Let's kick things off with Section 1, the dawn of engineering, from survival to structure. And we're going to jump back roughly 8,000 years, to a time when a severe climate shift literally forced humanity to become engineers. And trust me, it wasn't about intellectual curiosity back then. It was just about sheer survival.
Okay, so picture this. Going way back to 11,000 BCE, northern Africa was actually lush and green. Scientists call this the African humid period. And even back then, early humans were already looking up at the sky to track their world, building the earliest known stone calendar at Nabta Playa around 7,000 BCE, just to chart the sun's movements. But then, right around 5,000 BCE, something massive happened. A tiny, almost imperceptible shift in the Earth's axis triggered some seriously catastrophic consequences. It completely dried out the Sahara, turning it into this deadly, sun-scorched desert. This massive climate event left nomadic tribes desperate, pushing them toward the only real lifeline they had left, which was the Nile River.
Now, to survive the totally unpredictable and honestly often violent Nile floods, these nomads had to innovate, and fast. They couldn't just run away from the water anymore. So they started digging these intricate canals to actually control the flooding, capturing that water to irrigate the dark, super fertile mud. By systematically sowing seeds and then building massive silos to store all their extra grain, they officially became the world's very first engineers. And for the first time, they permanently settled down.
Which brings us to Section 2, Pyramids, Stars, and Mysticism, Reaching for the Divine. So with all this newfound agricultural stability, immense wealth, and a totally exploding population, there came this inherent need for order. And with that order came powerful rulers, the pharaohs, who had a deep, mystical desire to literally conquer death itself, using their brand new engineering skills.
Now keep in mind, early engineering relied heavily on trial and error. It definitely wasn't perfect right out of the gate. Take the famous Bent Pyramid, for example. It was honestly a massive mathematical disaster. The builders got a little too ambitious and used a really sharp 54-degree angle for the walls. Well, the immense weight of those stones just caused the whole structure to violently buckle and bend right inward. It still stands today as humanity's first major, grand-scale engineering failure.
But hey, they learned incredibly quickly from those mistakes. That kind of iterative learning directly led to the absolute architectural marvel that is the Great Pyramid of Giza, built by King Khufu. Get this, they used a staggering 2.3 million massive stone blocks to build it. 2.3 million. And here's the real kicker. They managed to align this gigantic structure perfectly to true north without a single magnetic compass. No compass. They just used the stars, some really simple tools, and sheer human ingenuity.
What's really fascinating here is how all this meticulous engineering was just so intimately tied to mysticism. Have you heard of the Orion correlation theory? It suggests that the Egyptians literally mapped the stars right here on Earth. The 3 pyramids of Giza are actually said to align perfectly with the 3 stars of Orion's belt. So they were engineering these literal mountains of stone with pinpoint precision, but for a totally spiritual purpose, to help guide the pharaoh's souls straight to the afterlife. Science and spirituality were just completely intertwined back then.
And you know, this desire to map the heavens and figure out the invisible forces of the world, that wasn't just an ancient Egyptian thing. Throughout all of history, we see this classic human attempt to categorize the unknown. Long before we had modern formulas, we relied on mystical frameworks. You can see it so vividly in historical texts from totally different eras and cultures, like the famous classical manuscript Shams-ul-Ma'arif, also known as the Sun of Knowledge. It perfectly shows our deep-seated human drive to find patterns, meaning, and actual rules in the universe, even if those early rules were firmly rooted in the esoteric and the spiritual.
All right, moving on to Section 3, The birth of physics, formalizing observation. Because eventually, humanity's heavy reliance on all that mysticism transitioned into something vastly different. That inherent desire we had to find cosmic patterns, it evolved into the formal, calculated, and testable observation that we now call physics.
Slowly but surely, the scientific method started replacing those mystical assumptions. This huge shift was championed by some seriously brilliant, relentless thinkers over the centuries, people who basically started demanding proof over belief. We start way back with Thales in ancient Greece. He actually used early geometry to measure the heights of those very same pyramids. Then, jumping to the 3rd century BCE, you've got Archimedes discovering the principles of buoyancy just by rigorously observing water displacement. Fast forward a bit to the 16th century, and there's Galileo. He didn't just casually look at the stars. He built telescopes and literally rolled objects down inclines to formalize how we observe time and distance. All of this centuries-long momentum finally culminated in the 17th century with Isaac Newton. He's the one who brilliantly tied earthly motion and planetary orbits together by establishing the laws of motion and universal gravitation.
So here's the really crucial point. Instead of just attributing motion to the varying moods of the gods, scientists started describing the universe mathematically. They began mapping everything down to highly specific behaviors. Think about being able to calculate the exact distance covered by objects undergoing constant acceleration, like precisely predicting the path and speed of an apple falling from a tree. Suddenly, the universe wasn't this unpredictable realm of magic anymore, it became a predictable realm of math.
Which brings us perfectly to Section 4, the science of measurement, defining the universe. Now, to actually communicate all these universal mathematical rules, humanity realized pretty quickly that we needed a strictly formalized, universally agreed upon language of measurement. I mean, we couldn't just keep using the length of a local king's arm or the size of a barley corn to measure things.
That realization led straight to the vital standardization we use today. Modern physics went ahead and established 7 fundamental, independent SI quantities, that's the International System of Units. This incredibly rigid framework is literally the bedrock of modern science. It's the only way we can ensure that an experiment performed over in Tokyo can be perfectly, exactly replicated all the way in Toronto. These 7 fundamental units, things like length measured in meters, mass in kilograms, and time in seconds, they're the absolute basic building blocks of discovery. They allow us to precisely measure and verify literally everything in our physical reality. Think about it. Without this standardized system, global scientific collaboration, advanced engineering, all of our modern technology, it would all be completely impossible. No smartphones, no space travel, nothing.
And that leads us to our final section, Section 5, Tools of Ultimate Precision, Beyond the Naked Eye. So the ancient Egyptians achieved absolute marvels using just water levels, simple ropes, and wooden sleds to align their massive stones. But now, let's shift our focus to the highly specialized tools that let us measure the microscopic. We're stepping way, way beyond what human biology can naturally perceive.
Enter the Vernier scale. Invented by the brilliant mathematician Pierre Vernier, this thing is an absolute masterclass in modern precision. It's so elegant. It basically attaches a secondary, smaller sliding scale right next to a main ruler. This super simple, yet completely genius mathematical addition lets us easily read tiny fractions of a millimeter. Stuff that would be completely, 100% impossible to gauge accurately just by using our eyes. Today, we take that genius concept and apply it to tools like slide calipers and the U-shaped screw gauge. These refined little instruments are absolute necessities in modern manufacturing and physics. They let engineers measure fractions of a millimeter perfectly. We're talking about confidently calculating dimensions as incredibly thin as the exact diameter of a single electrical wire or the thickness of a sheet of metal. Honestly, building airplane engines, life-saving medical devices, or even the tiny microchips inside the computer you're using right now, they all fundamentally rely on this exact tier of specialized precision.
And all this ultimate precision? It relies entirely on what we call the Vernier constant. Technically, it's defined as the difference in length between one smallest division of the main scale and one division of the Vernier scale. But really, just think of it like a mathematical magnifying glass. By comparing the tiny little mismatch between those two physical scales, we completely eliminate human visual error. It acts as this rock-solid mathematical baseline that basically guarantees absolute exactness in our measurements every single time.
When you step back and really look at the big picture, it's just an incredibly inspiring journey of human curiosity and resilience. I mean, we literally went from desperate tribes just trying to survive a dying Sahara to engineering massive mountains of stone, and finally to calculating the invisible fractions of our modern physical reality. It really leaves you wondering, doesn't it? With our ever-evolving tools of precision constantly pushing us further into both the microscopic and the cosmic, just how deep into the mysteries of the universe will our human quest take us next? Thanks so much for exploring this incredible timeline with me.